Hi everyone, this is continuation of the Kirchhoff's current law example. So in this video we'll look at another example which explains the Kirchhoff's current law. So in the given circuit, the supply 18 volt power supply gives a current of 8 amperes and here is the Ix which is given as 3 amperes and 13 ampere is coming through this Vx source. We need to find out the value of Ra. So for this question, we need to know the Kirchhoff's current law as well as a little bit application of Ohm's law. So as we quickly recall what is Kirchhoff's current law, it says the current entering the node is equal to current exiting the node. So I1 equals I2 plus I3 is nothing but Kirchhoff's current law. So here in this question, so 13 amperes of current is going through it. So here also it would be 13. Now Ix is given as 3 amps, which is going downward. So let's write it here 3. Now this is the node. Let's name it as A. Set node A if we apply the KCL. So we'll write it as KCL at node A. So current entering the node, let's say this current is going in this direction, be it I1. So we can say I1 is exiting the node and 3 amperes of the current is also exiting the node. So the only current which enters the node A is 13. So we can find out I equals 13 minus 3, which is 10 amperes. Now this 10 amperes of the current is going in this direction, right? And the current through the power supply, 8 amperes, is also entering the node. So the current entering this node, say it B, is 8 plus 10, and let's say current exiting the node here, be it I2. So if we apply the KCL at node B, it would be, so let's write it as KCL at node B. Okay. So KCL at node B, if we apply, the current entering would be 8 plus 10, which is equal to I3, which is I2, which is exiting the node. So it equals 18 amperes. Now 18 amperes is the current passing through this resistor Ra. But what we need to find out is the value of the resistance Ra, right? So to find out the value of the resistance, if you look at the Ohm's law, which says V equals I into R, right? Ra. So Ra is nothing but the potential difference across the Ra divided by the current passing through it. So current we already found out as 18 amperes and the voltage is also given 18. Why? Because this voltage, let's say it's 0 volt here. So the 18 volt will appear here as well at the node B. So the voltage at node B, and let's say it as node C. So which is voltage at node B minus voltage at node C divided by current, which is nothing but 18 volt, right? Because this voltage 18 volts appears across Ra. So 18 divided by 18, which is nothing but 1 ohm. So the value of the resistance Ra is nothing but 1 ohms. So that's all about this question. Thank you for watching the video. Stay connected towards the next application of Kirchhoff's current law. Have a great day.